Here's how easy it is to set up a partial flume. You're going to come here under linearization and you're going to go to user programmable, and then you're going to open the linearization assistant. Next, you will select flow measurement. All right, and then you're going to hit next. Now you got to tell the sensor what exactly do you want to set up. So you hit the drop down. If you hit the drop down menu and go to manufacturer definition, you'll now see down here where it's grayed out, it'll say partial flume. So next. Now here's where you're going to span it. This is where you're going to set up your range. So basically what you're going to do, distance B will be from the dome of the antenna to the bottom of the flume. Distance A is going to be the distance B number minus the head height in the open channel handbook. So now once you enter that data, next you're going to tell it the size of the flume. So I'm going to select a 2-inch partial flume. Next, I'm going to pick my flow unit. So I'm going to do millions of gallons a day. All right, now watch. Next. Now look, it automatically calculates your flow rate for you. This is not something you have to do. It's all automatic. And so now you're going to hit next. You get your summary of what you have requested and finish. You're now done. 5 minutes. Well, we allow 15 minutes for our technicians, but 15 on average, 15 minutes is all the time that's needed for setting up a partial flume. Same thing applies for the lift station too, which we'll discuss next. Now, also what you can now do, the system's now set up and ready to go. If you were to send the output from the C series to one of our signal conditioners, the 800 series signal conditioners, these signal conditioners have relay output and they have current output. So therefore what you can now do is bring this information into the signal conditioner, and now you can use it also for pump control. There you go. So that's the quick and easy for a partial flume setup. All right, I'm going to take us back to the PowerPoint just for a moment here. Okay, so here we go. So now let's look at how to set it up. So here we go. This is going to be now for a lift station. When the sensor is installed, if at all possible, try to find an area whereas you're not going to hit the fill string and you're going to try to miss that pump head down there. So we have a procedure for this. So because this is going to be a water-based application, the reflection returning back to the receiver is going to have a very high dynamic gain because we're using 80 gigahertz. And so therefore we get very, very high dynamic gains, which allows for better reliability and accuracy. So now this is what your lift station will look like the moment you start it up. Here we go. So when you start it up, this is going to be your vessel profile. Now let me explain exactly what you're looking at here, and then I'm going to explain what we're going to do. First off, mechanical floats. Got these mechanical floats down there. This particular one has just one float. Next, this reflection you see here, this is the pump head. So how this works, we're shooting a signal down in this vessel, and the red line you see here is what we call our echo curve or carrier, if you will. And then riding on this echo curve are these green humps with the 2 red dots. The green humps represent reflections returning back to the transmitter, good or bad. Now we have to learn out or map out the bad reflections so that it only tracks just the good ones. So now here is an issue you can sometimes have when setting up these lift stations. Most of your newer lift stations now, they'll put them in subdivisions at the end of subdivisions, and they have to lock them to keep people out. So therefore it has a metal lid on the top. And so as soon as you close that metal lid, what can happen sometimes, it can create noise. Basically what's happening is that the signal is going down, bouncing off your water level, and then it's coming up and hitting that metal lid. And now what this does is produces multiple echoes. So let me go on to explain. Back to this curve profile. So now this first one is going to be a float. This second one here is your pump head. The next one is the floor of the lift station. But now look out here in security. What is this? right? What happens is when you close that metal lid and you raise your level up above 60%, there is so much energy reflecting off that lid that it begins to replicate itself. So what's happening here is this big echo you see here is a multiple echo of this echo here. Now what happens to the sensor? When it sees this multiple echo, it now wants to spike itself down to 0%, trying to get to this echo. Now you don't see this problem every day because you have to hit a certain level in that lift station and it has to have a metal lid. Now if the lift station says open in the top, you do not see this. But now if it has a metal lid and you close it, then you could potentially see this problem. Now, here is the easy setup that will fix it. You're going to go into an area called false signal suppression. I'm going to demonstrate this to you in just a few moments. You're going to carry out a false signal suppression. That's step one. And then under the false signal suppression tab, there's an edit tab. And the edit tab is where you can custom build the false signal suppression to eliminate these problems. The automatic false signal suppression will only get you halfway there. You have to put the manual edits in next. Now, here's how this works. First manual edit, we're going to place it right here around the antenna. And so what this is going to do is prevent the gauge from spiking due to buildup. The second manual edit, we're going to place that around all your floats. And that'll take the floats out of the picture. And then the third manual edit is going to be around the pump head. And then the final manual edit will be here in security. Now, when you're setting up one of these lift stations, the first thing you're going to want to do, you have to expose all of the unwanted obstruction. So therefore, you got to pump this down to your low suction point to expose the pump head. You got to get this pump head into view so you can go in and map it out. You cannot map it out ahead of time because you don't know what the signature looks like until you pump it to the low suction point. So when you pump this guy down to the low suction point, you put that manual edit in there, and now the sensor will now work reliably for years to come. So now, let's go ahead and see what this looks like in the real world. And back to our echo curve. Now here we go. So as I explained earlier, this graph is your tank lying on its side. To the left of the white area here, this is going to be approaching the top of your measuring range, and to the right over here, the bottom of your measuring range. Now take a look. You see the black arrow here is indicating 110%. This system is already spiked. We have more than the normal amount of buildup that you will have on the sensor. We got actual over an inch or two of buildup we packed on that antenna just for this training class. So what has happened is that the sensor is now spiked to the buildup off the antenna. So now here we go. This is your fix. Now note that the gauge is currently in an upset mode. So step one, you select the false signal suppression. And now you're going to select create new. Your options are create new, extend, or delete all. But we're going to do a create new. Now next, you're going to put in the distance to the bottom of your lift station. So you click on the lift station echo, or you can pull out a measuring tape and measure it however you choose to do it, electronically or mechanical. So it says here place, that's distance. So it's 78.39 inches down is my level. So I come here and I'm gonna put in 78.39. So 78.39. And then note that whenever you change something on this in this DTM window, you're going to see that little pencil mark. So note that if you see pencil marks, don't forget to hit apply or execute to write the data. So here I'm going to do execute. Okay, now you can see that the blue line, which is called our false signal suppression line, has now advanced itself further downstream, and now note that my gauge is now reading correctly. The black arrow has jumped down to the actual level, and the actual level currently is at 9%. But we have to make sure that due to additional buildup, it does not jump back high again, and we got to make sure that it doesn't jump onto the pump head. So now here's what you do. We come down here to where it says edit false signal. Now, here's your final step. I'm going to zoom in to get my numbers. And it looks like my first number is going to be 0 to 10 inches. So I'll put 0 for my start, 10 inches for my end point. And then for my amplitude, 110. This is going to be the first echo, the first manual edit. Now, next, I'm going to put in a second manual edit, and this one is going to be for the float disappeared. All right, that's fine. So we go take out the pump head. All right, now next manual edit is going to be for the pump head. And since we did have that float in there before, and I remember seeing it, I'm going to go ahead and put the data in for the float. So the float started at 70. Our endpoint was 74. And then our amplitude was 50. This is the data I got off that float before it disappeared. It disappeared because floats, they move around, and so it's moving around on the water. Final edit, let's drop this one in. So our start would be 95. Our end is going to be 150. And then amplitude, 100. Now, here's where I'm getting all this data. So you zoom in, edit number 1, unzoom, zoom in. Well, I took out the float already. So we come back here, and all you do is place your mouse pointer up over the top of the area you wish to zoom in on and drag it down and over. And now I got my starting point right here on this scale, and I got my end point. Now next, the final one down here, what we're going to do is figure out where we're starting. This is much easier. What you're going to do for that last and final edit, what you're going to do is take your distance B value. So whatever distance B is, you're going to add 10 inches to it and make that the beginning of your manual edit. So my distance B is 85 inches. I'm adding 10 inches, as you can see here, to make it 95. And then what you're going to do is take it completely off the scale. You can put in 150, you can put in 200, but just take it off the scale and make the amplitude 100, and then hit apply. The average setup time for a lift station should be approximately 15 minutes, but the wonderful thing about it all, you only have to touch it once. You get it set up correctly the first time, so you don't have to make that return visit. You think about the hundreds of thousands of lift stations around the country. Can you imagine the maintenance required to maintain these stations? And with this new package here, a lot of that maintenance will go away. And then you got to think about the safety issues as well, because there's a lot of, bacteria and stuff in the water. So here comes my final manual edit. You see this in just a moment. There you go. This is what your lift station should look like. Now, you see this area out here that we put that last manual edit? That ghost echo will only show up when you fill the level above roughly about 60%, and then you have a metal lid and you close it. That's when this echo will appear. So what you're going to do is go ahead and strategically place this manual edit ahead of time so that this does not happen. And so there you have it, a complete, reliable setup on a lift station.